Hello students, welcome back to our channel Diksha Karnataka. So as you know, your COMEDK exam is approaching. It is on May 12th. So hardly 19 days are left for your COMEDK exam. So in this video, I'll be discussing the previous year paper of 2023. Okay. So these questions are there, like 60 questions will be there in chemistry. So you have to practice similar questions and you can expect such questions in your COMEDK 2024 exams. So I'll be discussing how many questions we are getting from which chapter, what are the ways to solve it. So whenever you do questions, you should not like these level questions only you should practice so that you can get good scores, right? So let us see here. So in this there will be 60 questions. In this video, I'll be discussing the part 1, which like question number 1 to question number 30. Okay, let us start with the first question. Okay, and the PDF of this one will be available in the description section and will also be available in our WhatsApp channel. So the link of the WhatsApp channel will be there in the description section. That also you please join. Okay. So coming to the first question, which of the following hexoses, will form the same ozazone when treated with excess phenylhydrazine? Okay, so this is one of the very important question from the chapter Biomolecules. Okay. So now if you see here, phenylhydrazine, when we treat in excess, ozazone is formed. So this type of ozazone can be formed if the configuration of carbon 3 and carbon 4 are same. Okay, so this is there in your glucose, fructose and mannose. So the correct answer for this question is option number B. Okay, so you have to just understand when you are solving, properly analyze the papers, like what type of questions are asked and what is the level of the question. So this is very, I'll say, moderate level question. Okay, now going to the next one. Product of the following reaction is, so this reaction is from your alcohols chapters, right? So when you do HgOH whole 2 and then NaBH4, we get a compound, this one. Okay, here OH will be forming and we have this one and then here OH. Okay, so now what happens, there is a dehydration process taking place and we will get this compound as like this. Okay, O here, then I'll connect. Okay, so we can draw it in different way here. Just a minute. So you can just count the number of carbon here. I'll get, this is 1 carbon, 2, 3, 4, 5 and this O is my 6th member, right? So I'll get a compound 6-membered ring. Okay, so I will number it like this. This is 6, this is my 5th, and then we have on the 5th carbon I have 2 methyl groups, then 4th carbon. The 4th carbon is connected with another chain, so I can do it like this. Then we have the 3rd carbon, 2nd carbon and 1st carbon, right? So you can see this product where we are getting, this is your option number B, right? So the correct answer for this question is option number B. Reaction based question, easy one. Next, okay, this question is from your polymers chapters, which is from the deleted portions. Okay, so you need not worry for this type of topics. Which of the following is an example of step growth polymerizing? This is the answer is nylon 6,6. Next question, when acetophenone when reacted with a base C2H5ONa yields a stable compound which has a structure of. So this one, if you know, we have acetophenone, that is CH3 C double bond O and a phenyl group, right? Now when you do any base is there, you are treating, you can see the 2 molecules have been there of the same type. It is nothing but your aldol condensation, right? So CH3 C double bond O. Okay, so now how to write the product quickly? So just you have to do, see, this is my carbonyl carbon, this is the alpha carbon, right? So you have to connect this carbon to this carbon. First step, connect this carbon to this carbon, then remove one H from here. Okay, so we will remove one H. So how many H is left now? We are having 2 H here, and then we have to make that H what you have removed here, you can add to this O group. Okay, so we'll get OH, right? But now if I write this product here like this, it will be pH. I'm writing pH, then we have COH, then it is connected to CH2, then we have C double bond O and then pH, right? Now what happens here, there can, you can see double bond formation is there. So we can heat it and we will get pH, C double bond CH2, and then we have C double bond O, pH. Okay, one more CH3 group is there here, which I forgot to mention, right? So the correct answer for this question is option number A. Next, Gabriel phthalimide synthesis is used for this. This topic is from your aldehydes chapter, aldol condensation, very important topic. So you can just write down the topics from where the questions are being asked, right? Okay, next this question is from amines chapter. Gabriel phthalimide is only used for the synthesis of primary amines. Correct answer is option number A. So when you study this one, learn about its mechanism. Okay, next. Okay, so this question is incomplete. I'll try to complete this question here. It is like C triple bond N, okay, reacting with CH3MgBr and then hydrolysis. Okay, this is the question. So if you see here, first it is Grignard reagent. We can add Grignard reagent whenever you want to add. Just think plus and minus. Okay, magnesium will be plus. This is minus. This is minus. This is plus. So this part will go and attack here. So we will have C double bond N MgBr, okay, and here we have CH3. Now what happens in hydrolysis? This part will break and we will get, okay, so in the question here OCH3 group was there, so this one will remain as it is. Okay, this is in the question. Okay, I didn't do any reaction here, that was there already in the question. So I'll get C double bond O CH3. Okay, so here is OCH3 is there in the meta position. Okay, so this is the OCH3 group. Okay, so the correct answer for this question will be your option number D. Next, so this question is from where, if you tell, it is also from your amines chapter. Okay, so these are, I'll tell all are moderate level, not very easy, but moderate level question. Pick out the incorrect statement from the following. So again the question is from biomolecules. Okay, so glucose exists in two different forms, that is alpha and beta. Yes, this is correct statement. Then alpha D and beta D glucose are anomers. Yes, this is also correct. Alpha D and beta D are enantiomers. No, they are not the mirror images of each other, right? So this is incorrect. Next, cellulose is a straight chain polysaccharide made up of only beta D glucose units. This is correct. Starch is a mixture of amylase and amylopectin. Both contain unbranched chain. This is incorrect. We know amylopectin is a branch structure, right? So this is incorrect. So which two statements are incorrect? 3 and 5 only. Correct answer for this question is option number D. Now let us see next one. This is also from your deleted portions. I think this chemistry in everyday life or some that chapter. That is used, drug that is used as antipyretic and analgesic is your paracetamol. Okay, option number C. Next, ozone in stratosphere is depleted by, we know this is in the haloalkanes, haloarenes also we know, chlorofluorocarbons. So that is your option number B. So this is both, you can include it in haloalkanes chapter and also in the environmental chemistry. Okay, next, which of the following is incorrect? Primary alcohols are easily oxidized to aldehydes, which are oxidized to acids with the same number of carbon atoms. Yes, this is correct. Secondary alcohols are very easily oxidized to ketones, which are oxidized to acids with same number of carbon atoms. This is incorrect. Once the ketone is formed, we cannot oxidize it to the same number of carboxylic acid. The carbon bond has to break. Like for example, if you have CH3COCH3, okay, and you further oxidize it, one of the carbon-carbon bond has to break. Okay, so we will get one as CH3COOH and another as HCOOH. Right, so you can see this is having 3 carbons, this is having 2 carbons now. So we will not get with the same number of carbon atoms. Secondary alcohols are easily oxidized to ketones, which are oxidized to acids with lesser number of carbon atoms. This is correct. Secondary and tertiary alcohols on oxidation form acids with lesser number of carbon atoms. That is what we have explained. So the incorrect statement for this is option number B. Next, rank the following compounds in the increasing order of basicity. Okay, so now if you see for basicity, first of all, the one which can donate easily, whose lone pair is not involved in any kind of resonance. So if you see this one, CH2NH2, The lone pair present on this one is not involved in any kind of resonance. So that will have the highest basicity. So where 2 is there at the end, we can take those options only. Let us eliminate this one and this one. Okay. Next, if you see here, one electron withdrawing group is there, here no electron withdrawing group is there, right? So definitely 1 will be greater than 3, right? But if you see here, 1 is less than 3, so the 1 will be greater than 3, so this option will come. Now this one is it has equal, like, two similar resonating structures, so that is why this NH2 is also not available. It will have the least basicity. So the correct answer for this question is option number C. Okay. Once again I'll tell here, because of same resonating structures, okay, the basicity of the compound decreases. Next, ammonical silver nitrate forms a white precipitate easily with. So this reaction will happen where terminal alkynes are there. Okay, so terminal alkynes is here. So the correct answer for this question is option number A. Next, so this question is from your hydrocarbons chapter. Okay, alkynes part. Next question, which defects leads to decrease in the density of the crystal? So this question is from your solids chapter, which is in the deleted portions, right? So the correct answer for this question is your Schottky defect. Okay. Next one. Okay, this is important question from your chemical equilibrium, and little calculation based question is there. So first of all, one reaction is given, 2NO gives N2 plus O2. The K1 value is 2.4 into 10 to the power of 20. Okay. Next question is, next reaction is NO plus half Br2 gives us NOBr. Okay. K2 value is 1.4. Okay. Now you have to calculate the Kc for the reaction. So the reaction given is half N2 plus half O2 plus half Br2 gives NOBr. So we have to arrange these reactions to get the desired reaction. Now if you see, N2 and O2 is in the first reaction, but they are on the product side. In the required equation, they are in the reactant side. So we can reverse the first reaction. Okay. So if you reverse the first reaction, we will get N2 plus O2 gives 2NO. So when a reaction is reversed, the equilibrium constant becomes inverse of that one. So here what will be this one? This value will be 1 by 2.4 into 10 to the power of 20. Okay. Now here we need only half N2 and half O2. So we can multiply the whole equation with half. So if I multiply the whole equation with half, I'll get half N2 plus half O2 gives 2NO. Sorry, gives NO, right? So now if the reaction is multiplied with half, the K value should be taken square root, right? So what is the new K dash here? 1 by 2.4 into 10 to the power of 20, its square root. Okay. Now the reaction which is given to us is this one. So I'll erase this reaction in between. So now if you add these two reactions, we will get the desired reaction. So you can see here, NO can get cancelled. We are left with half N2 plus half O2 plus half Br2 is giving you NOBr. Now when the two reactions are added, their K value should be multiplied. So what will be the K final? It will be equal to 1.4 into 1 by 2.4 into 10 to the power of 20 square root. Okay. So once you do the calculation, the correct answer for this question will be 8.96 into 10 to the power of minus 11. So you can check the calculation. Correct answer for this question is option number A. Next, which of the following is correct regarding the Henry's law? So gases react with solvent chemically. So there is no chemical reaction when a gas is dissolved in water. So this statement is incorrect. Next one, pressure and concentrations are not too high. This is correct. Temperature is not too low. So it is like all optimum conditions are required. Gas does not change its molecular state in the solution. That is neither dissociates nor associates, right? The statement is also correct. So the incorrect statement is option number A. Next, tertiary butyl chloride preferably undergoes hydrolysis by, so we know for SN1 mechanism it is 3 degree, 2 degree and 1 degree. So the correct answer for this question is option number A, that is SN1. Next, which of the following is not true? Enthalpy change is negative for adsorption. Okay, so this question is from surface chemistry. Okay, this is also deleted portion. Okay, so the enthalpy change is negative for adsorption of a gas in the solid. This is correct. Increase in temperature favors adsorption. This is incorrect. Okay, once the temperature increases, adsorption decreases. So the incorrect statement is option number B. Next, which of the following represents the correct order of decreasing bond order? So calculation of bond order we can easily do. So you have to remember one table here. Here you have to mention the total number of electrons and here it is bond order. Okay. So if the total number of electrons will be 14, for example in case of N2, then the bond order will be 3. Then 15 it will be 2.5, 16 it will be 2, 17 it will be 1.5 and 18 it will be 1. Similarly this side 13 it is 2.5, 12 it is 2, 11 it is 1.5 and 10 it is 1, right? So now you can just calculate all the bond order and then we can arrange them in the given question. So C2 2 minus. So carbon has 6 electrons, 6 plus 6 12 and then 2 charges there 14. So 14 electrons means bond order of carbon C2 2 minus is 3. Now coming to O2 2 plus. O2 is 8 plus 8 16, 16 and sorry this is O2 plus, okay. This is O2 plus. So 8 plus 8 16 and then minus 1 we will have 15 electrons. So 15 will have 2.5. Next is O2 minus, okay. O2 minus is again 8 plus 8 16 plus 1 17. So 17 is 1.5 and this one is He2 plus, okay. So this is also He2 plus. So for He2 we cannot apply this one, okay. So for that you have to do He plus. So total number of electrons will be 3. So if we write the electronic configuration, sigma 1 is 2 and sigma star 1 is 1, right. So now if you calculate the bond order here, half of number of electrons in the bonding orbital minus number of electrons in the anti-bonding orbital. So I'll get 0.5, right. So this bond order is 0.5. So now if you see the order, this is first, then this one, then this one and then this one. So the correct answer for this question will be option number A. Okay, next, in a 0.2 molar aqueous solution, lactic acid is 6.9% dissociated. So when this percentage is given, so this question is from your ionic equilibrium chapter, right. So whenever the percentage is given per degree of dissociation, that we represent it using alpha, right. So alpha value is 0.069 and the value of dissociation constant, that is Ka. Ka value will be C alpha square by 1 minus alpha, but alpha 1 minus alpha we can ignore it. So if we solve this one, we will get C value is your 0.2 molar, okay, and alpha square is 0.069 square, okay. So if you solve this, we'll be getting value around 9.5 into 10 to the power of minus 4. So the correct answer for this question will be option number B, okay. Now let us see the next question. Pick up the correct statement. Dipole moment of ammonia is due to the orbital dipole and resultant dipole in the same direction, right. This is correct. We have this one NH3, sorry, in ammonia we have a lone pair here. So this is the lone pair in ammonia. So all the dipole moments are towards the more electronegative atom, that is here nitrogen, and here is towards the lone pair. So these all are in the same direction. So that is the correct statement. Next one, O2 and H2, so bond dipole due to polarization. So this is incorrect statement. Dipole moment is not a scalar quantity, it is a vector quantity. Then in BF3, bond dipoles are 0 but dipole moment is higher. No, dipole moment is 0, okay, bond dipoles are higher. So the correct statement for this question is option number A. Next we have total number of sigma and pi bonds in ethene molecule. So if you draw ethene molecules, we have, this is the structure. So we have 1, 2, 3, 4, 5, right? So these all are sigma bond and we have 1 pi bond. So 5 sigma and 1 pi bond, that is option number B. Next, a buffer solution has equal volumes of 0.1 m NH4OH and 0.01 m NH4Cl. The pKb of the base is 5, the pH is. So this is the question from ionic equilibrium again, and this is very direct, easy formula based question. Okay, so for any basic buffer, what is the calculation formula to calculate the pH? Or pOH is equal to pKb plus log of salt by base. Okay, so now if you just substitute the values, here we have base is NH4OH and salt is NH4Cl. So let us substitute the values here. pKb is 5 plus log of salt concentration is 10 to the power of minus 2 and base concentration is 10 to the power of minus 1. So I'll get 5 plus log of 10 to the power of minus 1. So I'll get 5 minus 1, that is equal to 4. But this is equal to pOH, right? The question has asked you to calculate the pH. So what is the relation between pH and pOH? pH is equal to pH plus pOH is equal to 14. So if pH is equal to 4, then if pOH is equal to 4, then pH will be equal to 10, right? So pH will be equal to 14 minus 4, that is equal to 10. So correct answer for this question will be option number A. Next. Okay, so oil of wintergreen. So this is a compound, that is your first option number A. This compound is called as oil of wintergreen. Okay, so this is the fact-based question. Next, assuming, so this question we have come to electrochemistry now. Assuming no change in volume, the time required to obtain the solution of pH is equal to 4 by electrolysis of 100 ml of 0.1 m NaOH using current of 0.5 ampere will be. Okay, so this question is little tricky. You have to understand what is being asked here. So pH is equal to 4 means what is the concentration of H plus? H plus concentration is 10 to the power of minus 4. Now if I calculate the number of moles, number of molarity formula is number of moles by volume in ml into 1000. Then what will be equal to number of moles? Number of moles will be molarity into volume by 1000, right? So what is the molarity value here? Molarity is 0.1, volume is 100 ml divided by 1000. So we'll get 0.01. Okay, so this is the number of moles, 0.01. Now if you calculate here the mass of NaOH, okay, because we need to convert it into mass, so we'll get 0.01, okay, into 40, that is 40 is the molar mass of NaOH, right? So we'll get 0.4, okay, so we'll get 0.4. Okay, so now this is the mass deposited. You have to calculate the time for this one. So if you want to calculate the time, we have Faraday's second law, first law, that is M is equal to Z into I into T. So here mass deposited is 0.4. Okay, Z will be equal to 40 divided by 1 into 96500 into I is your 0.5 ampere and time we have to calculate. So if you solve this, T value will be 1.93 seconds. Okay, so the correct answer for this question will be option number A. Okay, now, so just check this calculation, this part once again listen. First we are calculating the H plus concentration, then we are calculating the molarity. After calculating the number of moles, you have to convert it into mass, okay, because the thing which is getting deposited is NaOH, right? So after calculating the mass, we can use Faraday's first law to calculate the time. Okay, next question. So this question is also from your deleted topic, solids chapter. So in a normal Spinel type structure, the oxide ions are arranged in CCP structure. So for CCP structure, the number of atoms is 4. If the number of atoms is 4, then I can say tetrahedral voids will be 8, octahedral voids will be 4. Okay. So now if you see 1/8 of the tetrahedral voids are occupied by Zn2 plus. So Zn2 plus will be 1/8 of 8, that is equal to 1. And next is 50% of the octahedral holes are occupied by Fe3 plus. So Fe3 plus is occupying 50% of the octahedral voids, that is So 50% of 4 will be 2. So the formula will become Zn is 1, Fe2 and O4. So the correct answer for this question is option number A. Okay, next. Which of the following compounds would not be expected to decarboxylate when heated? So when a carbon dioxide molecules leave, whatever compound is formed, if that is stable, then decarboxylation will take place. So if it forms any unstable species, then decarboxylation will not take place. So if you see in this first one, if we have decarboxylation in this state, okay, so this bond will come here, this one will go, and this negative charge here is formed, right? So this negative charge is stable due to the resonance with this carbonyl group. So this can decarboxylate. If you see this one, we have here OH and we have here also OH, right? So if any one molecule gets any one side it undergoes decarboxylation, we'll get a negative charge on this one, which is also stable due to resonance. So this will also undergo. Now you check this one. Suppose this one undergoes decarboxylation, we will get, so I'll show here, this O comes here, this bond comes here, and a negative charge is formed here. So if you see the structure of this one, this negative charge is not stabilized by resonance, okay? It is one more carbon is there, so this does not get stabilized by resonance. So the correct answer for this question will be option number C. Here also negative charge will form here, which is stabilized by the resonance, okay? So the correct answer for this question will be option number C. Next, which of these molecules have non-bonding electron pairs on the central atom? So this question is from your chemical bonding, okay? So it doesn't have any non-bonding electron pairs. So we have to see the structure. Okay, which of the following molecules have lone pairs? Okay, so we have to draw all the structures and check. SF4, if you know, its structure is seesaw shape with one lone pair. So it has, now if you see ICL3 structure will be with two lone pairs. Okay, so this also has lone pair, and SO2 structure will be, okay, so this also has lone pair. So all 1, 2 and 3, all the 3 structures are having lone pair. So the correct answer for this question will be option number D. Next, for a cell reaction AB2 plus A2 plus B, where the reaction is like this, the standard enthalpy is given 0.295 volt and the equilibrium constant is asked, right? So if the equilibrium constant is asked, we know the formula E naught of the cell is equal to 0.059 by N log K. Okay, so E naught of the cell is given, N value will be how much? You see A2 plus B2 plus 2B. So a number of electrons involved is 2. So E naught of the cell is 0.295, 0.059, N value is 2 log of K. Okay, so now this one we can write it as 0.3 and this one I can write it as 0.03 log of K. So which equal to 10 is equal to log of K. So if you solve this one antilog on both sides, K is equal to 10 to the power of 10. So the correct answer for this question will be option number A. Next, which of the following shows negative deviation from Raoult's law? So you can remember many examples for positive and negative deviation. So benzene and chloroform will show negative deviation. Correct answer for this question will be option number B. Next, here one data you have to write, Kb value was 0.1. Okay, so 5 gram of 0.5 gram of non-volatile water soluble compound X is dissolved in 100 gram of water. The elevation in boiling point is found to be 0.25 Kelvin. The molecular mass of the compound X is. So this question is from solutions chapter, direct formula based question on the colligative properties, that is elevation in boiling point. So we have this formula delta Tb is equal to Kb into M, right? So delta Tb value is 0.25, Kb value is 0.1, then molality value is given mass by molar mass, given mass is 0.5, molar mass we have to calculate into 1000 by mass of the solvent is 100 grams, right? So now if we solve this, we will get M as 20 gram per mole. So the correct answer for this question will be option number C. Okay. So these were the 30 questions of part 1 from COMEDK previous year paper 2023. So just solve these questions and practice it again so that you can understand the level of exam and the type of questions asked. Okay. So if you have any doubt in any question, you can comment. I'll explain it in my next video. And if you have found this video helpful, please like, share and subscribe our channel. Thank you.